All right, so this is our Algebra 2. Let's see, this is review 1 through 20, part 2. Part 2. Okay, so you're going to be given an f of x equation, something like 7x squared, let's see, plus 6x minus 1. Okay, you're going to be given a g of x, something along the lines of negative 10x plus 7. Okay, you're going to ask to find f plus g of x. Okay, it's fairly simple. What do I do with those two equations? Add them. So I'm going to write it out. What do I write? 7x squared plus 6x minus 1. Okay, minus 10x, he says, plus 7. So we don't change anything, right? If that had said we wanted f minus g of x, what would I have had to do to keep from making a mistake? I would have had to put plus 10x minus 7 because I would be distributing that negative to every term in g. Okay, from here, what am I doing? Combining like terms. Does 7x squared have a like term? Okay, so it just stays. What about 6x? Okay, negative 10x, so it becomes what? Negative 4x. I've got negative 1 and positive 7. Positive 6. Yep. Okay, so pretty simple. Looks like a lot. There's really not a lot there. Okay, let's move on to number 6. Okay, similar circumstances, but different. All right, let's say we've got 6x cubed plus 8x squared minus 8x plus 5 minus 4x squared plus 8. Okay, so basically the very situation I was warning you about in the last question becomes a reality in this question. What do I need to do first? Distribute the negative. Now, the biggest mistake that people make with this is they do distribute it to the 4, but they don't distribute it to the 8, to the second term. So as I rewrite this, I'm writing 6x cubed plus 8x squared minus 8x plus 5 minus 4x squared minus 8. Now, do what? Combine like terms. Do I have any x cubes? Okay, just the 6x cubed. What about my x squareds? All right, so what do I get? Positive 4x squared. I got negative 8x. Is there anything with that? Negative 8x. I got positive 5, negative 8, negative 3. That's my answer right there. So far, seems pretty easy, right? Nothing too bad here on part 2 as of yet. Okay, 7. Okay, 7. I think you've seen a question like this. Let's say x minus 3, and I don't know if I'm going to be able to do this in such a way that you're going to get a nice, neat number or not, but because I'm just making up numbers. Okay, so this is based upon a determinant. It's a 2 by 2 matrix. Okay, so let's just talk about the setup. What do we do first? What's that? Okay, so what we would write is we're going to do x minus 3 times 2. Okay? X minus 3 times 2. Then what? Equals what? Okay, so minus 9 times 3, right? Do not forget the minus. Equals negative 15. Okay? What do I do now? Okay, do we all understand how this was set up? Okay, top left times bottom right minus bottom left times top right is going to be the determinant. So what do I need to do with this section here? Distribute the 2 to the x and the negative 3. So I get what there? 2x minus 6. Okay, and now negative 9 times 3. Negative 27 equals negative 15. Okay, what do I do on the left-hand side? Combine like terms. So I got 2x, I got negative 6, and negative 27, which would be what? Negative 33. Negative 33 equals negative 15. Now what? Add 33 to both sides because we're trying to isolate x. Okay, so I have 2x equals what should be a positive 18. Okay, do what now? Divide by 2, divide by 2, x equals 9. That's really great because I thought, hey, I'm just throwing some stuff in here. So that's going to be your final answer on this question. Okay, do we understand our steps? Okay. Understanding the steps is all that we're really doing here. I'm giving you an example, teaching you the steps because I'm not giving you the numbers. So I don't want you to memorize the numbers. I want you to memorize the steps. What did he do first? What did he do next? Okay. This one is a question that you've seen before. I'm tempted to try to find a different version of it because you've seen it and I don't want people to just memorize the answer. Okay. Oh, this is number 8. Sorry. Okay. All right. I want some random numbers. 18. Try to give me single-digit numbers just for the ease of it. 8, 7, 5, 6, 2, 1, 0, 3. Let's try negative 4. Okay. What this wants is it wants the determinant. Okay, we have to find the determinant of this. Okay, so what I'm also going to do, okay, it's going to give you this. I'm going to write it out. Sorry, it's subtraction first, I believe. Is it subtraction first? It's add first. Add first, then subtract. So I'm going to throw up the same thing here and here of the exact same sets. Okay, which I have shown you before, but I did not see people do on their last test. Okay, this should not take terribly long if we're efficient at what we're doing. Okay, so first we get 8. We bring it down here. Okay. It's going to be top left first. It's going to run across our top row. Left, middle, last. Okay? Times the determinant of the 2 by 2 matrix here. Okay? So 2 times negative 4 minus 3 times 1. Okay? Plus, we get 7. Okay? Line runs across and down, leaving me with the determinant of 610 negative 4. So 6 times negative 4 minus 0 times 1. Okay, fine. Bring down our subtraction. We get 5. And we use the determinant of this inside matrix here. So 5, 6 times 3 minus 0 times 2. Okay, come back. We will do our inside stuff. So we got 2 times negative 4, which is negative 8. Minus 3 plus 7. We got 6 times negative 4, which is negative 24. 0 times 1 is 0, so we aren't subtracting anything. Okay, minus 5. We got 6 times 3, which is 18. Minus 0 times 2, which is 0, so we're just left with that there. Okay, we can go ahead and simplify our 8 minus 3, or negative 8 minus 3, and get what? Negative 11. Okay, plus 7 times negative 24, minus 5 times 18. All right, I know this is negative 88. I don't know what 7 times negative 24 is, but I do know it's negative, so if you guys can help me out there. 7 times negative 24, negative 168, okay, and negative 5 times 18, negative 90, okay. So we're going to get a fairly sizable negative number here. Okay, negative 88 minus 168 minus 90. Probably going to be somewhere around negative 300. Negative 346. Okay, for sake of time, we're not going to plug this in our graphing calculator to check it, right? We should have done everything right. If we did something wrong, our procedure is still right. I may have just added or subtracted or maybe multiplied wrong somewhere. Okay, so on your own time, you might check that. Does everybody know how to use your graphing calculator to find a determinant of a 3 by 3 matrix? Okay. Okay. All right, so we are up to, what, number 9 now? Okay. Use Kramer's rule to solve. Negative 3x plus 3y equals 7. Again, I'm not guaranteeing my numbers are going to come out to anything neat or orderly. Okay, but if I'm solving for x, okay, again, so you can already tell that a big part of this test so far is knowing how to find determinants. Okay, if I'm solving for x, I'm going to plug in my solution values for the x position. So I'm going to put 7 and negative 11 here, 3 and negative 5 here. Do we understand that part? Okay, for the lower determinant, everything just stays in its position. So negative 3, 3, 6, negative 5. And then we find our determinant. So we have 7 times negative 5 minus negative 11 times 3. We've got negative 3 times negative 5 minus 6 times 3. Let's see, negative 3 times negative 5 is 15. 15 minus 18 is what, negative 3? Negative 3 in the denominator. 7 times negative 5 is negative 35. Okay, minus negative 11 times 3, so that would end up being plus 33. Okay, so what do we end up with? We end up with what, negative 2? All right, so my x equals positive 2/3. Okay, now you can solve this different ways, and I'm not going to care if you solve different ways, but because it's saying use Kramer's rule, and Kramer's rule has been one of those things that we've struggled with, that's why I'm solving it this way. Does that make sense? Okay. Yes, did I do something wrong? Okay, we'll take a look at it tomorrow. Okay. Okay, now down here, right, we know that our denominator matrix is going to be negative 3. So I don't have to do anything else there, but I do need to substitute. So I'm going to have negative 3, 6 here, but I'm going to have 7, negative 11 in this position. So the solution moves over to the y's. Is that it? Okay, all right. So I will stop there. I'll probably work on the rest of this tonight once everybody's gone, make a part 3 out of it.